Chemistry can be complicated. Today we're going to be looking at why the atomic radius changes through the periodic table, why it decreases as the periodic table moves up and over to the right, and give you kind of a foundational understanding of that trend, which will help later on in your chemistry course. Hi, I'm Jess, and this is part of my series, Chemistry Can Be Complicated. Today we're going to be looking at the atomic radius. I'm going to be walking through a short description overview of the trend on the periodic table of the atomic radius, and then why exactly it follows that trend. It kind of can seem counterintuitive whenever you think about the size of the atom based on whether or not you have more protons and electrons and everything like that, but I'm going to explain to you why it is the way that it is. Let's go. So here I have the actual trend. It is, I like to go by decreasing. You can always just do the arrows the opposite direction and say that it is increasing in that way, but it is increasing as you go, or I'm sorry, decreasing as you go up the periodic table and decreasing as you move right. And this is going to be two basic reasons why, one of them explaining the column of the periodic table and the other one explaining the row. But first we're going to be looking at some basic rules to kind of give you a little bit of an understanding of what we're going to even be talking about. One of them is that positive is going to be attracted to negative. So positive charge is attracted to the negative charge. In the same way, positive and positive repel each other, and negative repel each other. However, that doesn't really apply in this basics. What we're really going to be looking at is that positive is attracted to negative. So when we look at the basic layout of an atom, we have the center nucleus, which has the protons, and they are positive. And then we have the rings that we use to kind of simplify the image of an atom to make it a little bit easier to conceptualize. We have the electrons, and this is just the first ring. This would be helium, just with the 2 electrons and 2 protons. And knowing that positive and negative attract each other, this means that we know protons and electrons are attracted to one another. And this is going to go into the atomic radius, particularly on the row, and I'm going to show that to you here in a second. The two things that make up the atomic radius, the two things that affect the size of the atom, are going to be your layers and any compression. So like we said, it decreases going up and to the side, right? We know that the radius increases moving down because with each step down the periodic table, down a column, you have another layer of electrons. So here you have 1 shell, here you have 2 shells, 3, and I'm keeping transitional metals out of this, just keeping it simple, 4, 5, and so forth. And that makes it where the increased layers are going to obviously increase your size, which is the radius. So that being said, like lithium is larger than sodium. Now when it comes to the reason why the radius decreases moving across the periodic table is a little bit different. So you can think of it in the way of compression. For instance, if we have a fridge, a magnet, and then artwork. So when you're a little kid, you have artwork that you took home from school, and your mom wants to put it on the fridge, and so use a magnet to do that, right? And so the strength of this magnet pulling towards the fridge is what keeps that artwork there. This is just to say that this is how the fridge and the magnet interacts. We are going to pretend like the paperwork are the shells that electrons are in. Obviously, the outer electrons, which we're going to say is the magnet, just to simplify it, the outer electrons are not keeping the shells in place below it. However, assuming gravity isn't a thing, this magnet it has to work through those barriers. It has to move through these shells to move towards the fridge, which we're going to pretend is our nucleus. So that being said, if we have a unimportant rating of a magnet, say it's a scale from 0 to 10, 10 is the strongest magnet ever made, 0 isn't even a magnet. So we say this fridge has a magnet rating of 3 out of 10. This magnet has a magnet rating of 3 out of 10. And it's compressing against these papers, and it's doing a decent job. It's interacting with the fridge. It's making a connection. However, it has to go through these papers. It's a weaker magnet. So this interaction as a whole is going to be fairly weak. However, when we have the most strongest magnet you've ever seen, 10 out of 10 on our made up magnet scale, we are going to have a really strong magnet, because I said 10 out of 10, for our fridge, and then a strong actual magnet holding these papers. And what happens when there's something in between two very strong magnets is it's going to pull towards the fridge, but it's going to really compress. It's going to push all of those down. Say maybe one was a cardboard project that your mom kept a piece of. It's going to almost break through that cardboard and really trying to get to that fridge, which in this case is our nucleus, where this is our electron, and these are the shells. So in understanding that, as you move down the row, you still have the same number of shells. So if we were to apply our magnet scale to this, carbon has 4 valence electrons, and oxygen has 6 valence electrons. Carbon here is going to be a larger size compared to the oxygen being a smaller size in the atomic radius, because there's the same barrier of this inner shell from this level between the electrons and the proton. However, for oxygen, there's going to be more positives and negatives in total. So it's going to compress down towards the nucleus more than it would compress for the carbon. And because shells aren't a factor, because we are staying within the same row, then it compresses the overall size without any other factors and causes it to be smaller. So the same number of papers, the barriers or the shells in the case of an atom, but a stronger magnet combo, a stronger charge by having more protons and more electrons overall interacting with each other. This creates a stronger pull and creates more compression, therefore creating a smaller size, decreasing the radius. And that is it. If you guys have any questions in the comments, please let me know. I know it can be a little bit confusing. Chemistry is confusing. As you move up, there are less layers, so the radius is going to decrease because you just don't have as much stuff there. And then as you move to the side, the atom compresses more and more with the addition of more and more protons and more electrons equivalently, without the addition of more barriers between the nucleus and the electrons. And so it's going to compress and get smaller. Very small amount, but it will still get smaller, so that's why the radius decreases from left to right. All right, if you guys have any more questions, please let me know. I'm going to be going over a variety of basic general chemistry topics. If you guys are interested in any private tutoring, I'm offering online tutoring. My website is linked below, and I do have a discounted rate for any initial appointments. That way you can actually get an idea of how the session will go and try it out a little bit. If you like this video, please like and subscribe. And I know chemistry is hard, but we can get through it. All right, bye.